Okay, so recap. What the takeaway that you need to start like putting in the back of your mind is, with the unit circle, the name unit means singular because the radius is one length, which means that the distance all the way around, because the radius is just a 1, is 2 pi. So the distance all the way around is 2 pi. You do need to keep in mind the rotation in a positive direction, and then keep in mind if the distance all the way around is 2 pi, then if I only go halfway around the circle, then it's 1 pi, or just pi, which is equivalent to 180 degrees. Start tying those values together in your mind. 2 pi is 360, pi is 180, and then get comfortable with like slicing the pizza or slicing the pie for that matter, to understand that if from here to to understand that if from here to here is 1 pi, then from here to here would be half that, so pi over 2. So start getting comfortable with those numbers. Then we looked at finding what fraction have you gone around the unit circle. If you go 5/6 of the way, you just multiply it by 2 pi, but you keep it as a fraction. The big thing here was you don't type pi in the calculator, because if you do, you'll never get the fraction out of it. Then we were looking at the practicing understanding where is it going to land. If I say you were looking at 9 pi over 4, understanding where that rotation goes and then lands in what quadrant. Then we learned the word radian with the beautiful example of a spaghetti noodle, an angel hair pasta noodle, uncooked, measuring 1 unit. Then you cook it so it's a limp noodle, I guess you could say. And then you lay it across the unit circle, so that's 1 radian, which is the equivalent of about 57.3 degrees, which is not that important, just to understand that, okay, it's about 57 degrees is 1 radian. So 2 radians would land me, past 90 degrees if one of them is about 57. Then these are the 4 most important radian measures that you're going to see come up in the unit circle. I'm prepping you to be able to label the unit circle from memory. I'm prepping you to be able to label the unit circle from memory, and this is part of that process, is knowing, like, from the initial to the 180 is 1 pi, so then halfway would be pi over 2, all the way around would be 2 pi. To get this, you would count the half marks. So this is 1 pi over 2, 2 pi over 2, 3 pi over 2. What's this? 4 pi over 2, which is 2 pi. You should see, when you're counting it correctly, you'll see those checkpoints or anchor points. Then we got to this slide. We said we're going to start converting back and forth from radian and degree. We are leveling up to radians. We want to get away from degrees a little bit because that's more geometry based. We're in the pre-cal, college pre-cal. The relationship is, if you're trying to convert a degree or a radian measure, when you're converting it, you don't want to change its value, right? You just want to change its appearance. So, for instance, if you're converting like feet to inches, you're not trying to change the measurement itself. You're just changing the unit of measurement. That's why you use the fraction pi over 180 or 180 over pi, because those are equivalent. It's right here. Those are equivalent units of measurement. Let's catch up. It's no. Don't even get me started. Those are equivalent units of measurement. So if you stack them in the same fraction, because they're equivalent, that means that they're actually equal to 1. So when you are converting, you're not actually multiplying by a number that is changing its value. You're multiplying by a 1. It's just coded, I guess you could say. How do you know which fraction to multiply by? Whatever you're trying to get it in, what form you're trying to get it in, needs to be in the top of the fraction. So what I mean by that is if you're going to radian measure, you need to tie the word radian and pi together. Okay? If something is in radians, there's a pi. You'll see the pi every time. If it's in degrees, you're going to see the degree symbol without the pi, right? So if you're going to radian measure, the pi needs to be in the top of the fraction, which would mean that one. If you're going to degrees, then the 180 needs to be in the top of the fraction. So whatever you're trying to go to needs to be in the top of the fraction. This is not on your formula sheet. You will need to know this. What I would, like when you start this end of chapter 6 exam, what I would write is the ratio pi over 180, and then I would make a note, the top form is what I want. So then I know to switch it. You know what I mean? So then we practiced it. I'm going to repeat this practice question. It says convert to radians. That means we're going to pi. If we're going to pi form, then we need pi in the top of the fraction. So I take the 120 and I multiply it by pi over 180 because that's the form I want. And now it's a matter of going to your calculator and you're typing this in. Don't type the pi in, once again, or you'll never get the fraction. So 120, you have to understand that if you multiply 120 straight across, there's an understood 1 there. So if you just multiply straight across, you end up with 120 divided by 180, right? You're multiplying that straight across. And then you hit math frac. So 2 pi over 3 would be the radian measure for 120 degrees. So you try B. And I will tell you that B is a very ugly ugly fraction. Doesn't mean you're wrong. It's just ugly. So you should multiply. So we're going 2 radians, so we want pi over 180. I'm going to go to my calculator. I've got negative 297.25. If I multiply that straight across, it's going to end up dividing by 180. Math frac. Like I said, it's ugly. So the answer is negative 1,189 over 720 pi. So negative 1,189 over 720. You should know that I always write the pi with the top number. Some people write it out beside it. I tend to write it with the top so that I don't ever accidentally think it's in the bottom of the fraction, because it never is. So you just decide which way you like. Now, if I said to you, I want this in decimal form, because my math lab may ask for both formats, fraction form, decimal form. If I ask for decimal form, then you do need to enter pi in the calculator. So when you get this, you just hit times pi. So there's the decimal form. If we were round, I went to the nearest hundredth. So negative 5.19. I'm going to put approximately negative 5.19. Now, because you typed pi in the calculator, that means it's already in this number, right? So we don't write another pi out here, because we've evaluated the pi. We don't put a degree symbol because we're not in degrees. You would write radians to show that you're in radian form. Now let's practice going the reverse direction. Now it's in radian form. You're going to go to degree form. Okay? So 3 pi over 4. Notice the directions. This says 2 degrees, right? 2 degrees. So we're going to multiply by the degree 180 over its equivalent, which is pi. So 3 pi over 4 times 180 over pi. You should remember from just basic conversions that when you are converting something, that the form that you're getting away from should cancel. This is in radian form. In order for the pi to cancel, the fraction I'm multiplying by has to have the pi in the bottom, and that will cancel the pi out, right? Because that's the goal. We want degrees. So if you're ever doing this and you forget which fraction to multiply by, red means wrong here. Let's say you had a brain fart, you forgot, and you're multiplying by this. You should see a problem right here. Like pi times pi is pi squared. We're never going to have that. So that should be your clue. Like, wait a minute, I should switch that because it should cancel. So if you do forget that whole, I don't like how I slashed that out. Let me slash it this way. If you do forget when to use which fraction, and especially with radians, you should see a problem if you set it up wrong. All right, so then you go to your calculator. You got to know how to type this in. You can use the math print mode, so then you don't mess it up. I see 3/4 times 180. So alpha y equals 3/4 times 180, and you get 135 degrees. If you what? Did you type? You must have typed 180 over pi as well. Yeah. So if you enter the pi in the first fraction, it will only give you the correct answer as long as you also entered it in the second one. Yeah, because it's going to cancel it. All right, look at B. Make a note. Careful. Look at that GPS. Watch out. Object on road ahead. What's tricky here? It's in radians, right? This was in radians. What's the difference? There's no pi. That's the difference. So don't let that throw you off. But it's like up here, the negative 5.19 radian. It means the pi has been multiplied in. The good news is it doesn't change how we're going to convert it. It just changes how we type it in the calculator. So I'm taking radians. I'm going to degrees. Notice, I'm going to say note, there is no pi here. Because there's no pi, that means it's been calculated into that 8.5. So we got to calculate the pi out of it. Does that make sense? So 8.5 times 180 over pi. Go to your calculator. Since there is no pi in the 8.5, the pi does not cancel this time because it got multiplied into that 8.5 at some point. So 8.5 times alpha y equals 180 over pi. And you get 487 degrees. Which you may think that that's like super, super big. If you feel like that number is wrong, use your anchor values to check yourself. What's a full rotation? 2 pi. Well, I don't know what that is off the top of my head, so I got to go to my calculator and type 2 pi, hit enter. So that's 6.3 radians. So if a full rotation, which is 360 degrees, is 6.3 radians, then 8.5 radians should be well over 360 degrees. So check yourself if you feel like a number is off. Always go back to the anchor points to put it into perspective. Okay, go to the next slide. So this slide is showing you the radian and degree equivalents that will be labeled on your unit circle. In fact, this one to the well, one will be superimposed on the other. The difference between the two is that the one on the left is hitting the 45-degree reference angle marks. The one on the right is hitting the 30 and 60-degree reference angle marks. That's the difference in those two pictures. You are going to get to the point by 6.5 where you're going to label this from memory. I'm going to show you how to do it. So start to get comfortable with these fractions. So look at this. The 45-degree reference angle fraction in quadrant 1 is equivalent to pi over 4. So that works out nice. The 45 pi over 4. Then the 45-degree reference angle in quadrant 2, which is 135-degree rotation, is 3 pi over 4. Counting it out, this is us just practicing the counting. 1 pi over 4, 2 pi over 4, which reduces to pi over 2, right? Reduce the fraction. 3 pi over 4, 4 pi over 4, which reduces to 1, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, 7 pi over 4, 8 pi over 4, which reduces to 2 pi. You see that? It's just counting and reducing the fractions every time. And that's where we're going. I'm kind of laying the groundwork for it. Now, this is the takeaway right here. If no unit is given for a rotation, like they don't tell you the unit of measurement, then it's understood to be in radians. So if you don't see a degree symbol, then it's understood to be in radians, okay? How do you know when you're working with degrees? You will see the degree symbol every time. Okay? No secrets. And when we say the rotation, we are referring to like the angles formed after it opens up from that initial side in whichever direction. Okay, going back to the mid-chapter 6 exam, a couple of people got the question wrong on finding the complement and supplement. Some people got it wrong because you didn't find 2 of each. So I gave you half credit because it actually marked it all wrong. If you didn't put all 4, they wanted 2 positive, 2 negative. I looked at your work, and a couple of people had a positive and a negative, but then they quit, and it marked it completely wrong. So I went in and gave you half credit because you had 2 of the 4 right. If you had 3 of the 4 right, I gave you 0.75 out of the 1 point. So before I go to the next slide, let's just refresh and make sure that you really understand that whole coterminal and then complement and supplement. So this is just a refresher. You can write this on another sheet of paper, or you can just watch. It doesn't matter. That line is still crooked. The funny thing is my geometry class is actually covering complement and supplement right now. Obviously on a much easier scale. There we go. Okay. If I say to you, find me a coterminal angle with negative 240 degrees. Coterminal means I need you to either add or subtract a full rotation to it, and then tell me what you get. Well, a full rotation is how many degrees? 360. So if I wanted a negative coterminal angle, you would take the negative 240 and subtract 360, and what do you get? It's negative 600. Yeah. If I asked for a positive coterminal angle, you would take the negative 240 and add a full rotation. So what's that? 120? In terms of the visual, understanding what a coterminal angle means, it means, let's see, I'll do this one. So negative 240. Negative means it's rotating clockwise. So this is 90, negative 80. If I go all the way, that's negative 270. I don't want to go that far, so negative 240 would be right here, right? 120 goes counterclockwise and lands right here. So coterminal means that they land in the same spot. They may rotate in a different direction, but they land in the same spot. This is the, oh my word, this is the angle that we're talking about landing in the same spot. Complement and supplement, a little different here. Complement means what adds with it to equal 90. Supplement means what adds with it to equal 180. I told you a corny way to remember the difference between the two. It involved the letter C and the letter S that they start with. You can make a C into a 9, you can make an S into an 8, and that was how you were supposed to remember. So if I say, what's the complement of, say, 70 degrees, you would say 20. What's the supplement of 80 degrees? You would say 100. Okay? The reason I'm showing this to you is because we are fixing to do this exact same thing, but in radians. Same thing, but radians. So instead of 360, what's the radian equivalent? 2 pi, right? So instead of 90, okay, you have to think pi over 2. So instead of 90, now it's going to be, has to add up to equal pi over 2. Instead of 180, you have to think it's going to add up to equal pi. That's what we're doing, okay? So this is the next slide. All right. So let's make a note. The very first question says, find a positive angle and a negative angle that is coterminal with 2 pi over 3. Just say many answers are possible. Let's take some notes. So instead of adding or subtracting 360 degrees, right, we will be, I'm going to draw an arrow, which means we are, like, instead of that, here we go, we are adding or subtracting what? What's the equivalent to 360? 2 pi. So our angle that they give us is 2 pi over 3. They want a positive and a negative. Well, it's already positive, so if I want to keep it positive, I'll add 2 pi. This is where if you're not comfortable with getting a common denominator, don't you dare write 4 pi over 3. Don't you dare do that. If you're not comfortable with getting a common denominator, there is absolutely nothing wrong with letting the calculator do this ugly work. At some point, every single one of you learned how to add fractions. But for right now, it's okay if you can't do it like quickly in your head. Just go to your calculator. So we're going to add 2 pi over 3 with 2 pi. Do I need to enter pi? No. Just enter the number part. So alpha y equals 2 over 3 plus 2. You get 8 over 3. Make a note. You don't want to push the pi button because if you do, you're not going to get a fraction. So 8 pi over 3 is our coterminal angle with 2 pi over 3. Now, if I want a negative coterminal angle, I'm going to take that 2 pi over 3 and what? Subtract the 2 pi. Let me show you a calculator shortcut. You can go up to what you just entered, or you can hit second enter, which says entry. It'll repeat it and allow you to edit it. So negative 4 pi over 3 would be a coterminal angle. Learn the vocab words. Remember, I'm going to finish this word right here. Coterminal. Okay, remember, coterminal means they're separated by a full rotation. So if it's in degrees, it involves 360. If it's in radians, it involves 2 pi. All right, the next one. Find the complement and the supplement of pi over 6. Okay, let's refresh your memory. What radian or what degree measure does this represent? If I was going in a positive angle measure. This is 90 degrees, right? Okay, what's the radian measure for it? Pi over 2. If you forgot that it's pi over 2, let me show you how to get it every time. I always go to pi first because I know where pi is. It's pretty. There's no fraction. It's over here, right? This is 180 degrees or pi. Then I say to myself, well, if I only went halfway, it would be pi over 2. So that's how I always remember pi over 2. I always think of it's the halfway mark to pi. Okay, so if we are finding the complement, let's take some notes. We're finding the complement. in degrees, ooh, that was ugly. In degrees, that means they add to 90, right? But in radians, they have to add to what? Pi over 2. For the supplement in degrees, it meant they have to add to 180. But in radians, it means they have to add to pi. So they're telling us that we're working with pi over 6, that's our fraction, and we're going to find the complement and the supplement. Two ways to do this. One way is, like we said earlier, allow your calculator to do the dirty work in terms of the common denominator. If this is what it has to add up to, then that's the bigger number, right? So order does matter here. So pi over 2 minus pi over 6, and then we're going to write what we get. Don't type pi in the calculator. What is the understood number in the top of those fractions? 1. That's what you need to type in the calculator. I'm going to put a 1 as a dotted line so that you'll know that when you go to the calculator. So we're doing 1/2 minus 1/6. And we get 1/3, which means with our answer we would write pi over 3. So if I took pi over 6 and added it to pi over 3, I would end up with pi over 2. You could always confirm these by going in the reverse direction with it, right? So you could check yourself. I have to say it before you wreck yourself. Sorry. All right, now we're going to find the supplement. Remember, this is what it has to add up to, so that is the largest value. So we are going to take pi and subtract off pi over 6 to see what its supplement would be. I don't know about you, but I do like fractions, and I like when I can do them in my head. You don't have to. You can go to your calculator. You can type 1 minus alpha y equals 1 over 6. You end up with 5 over 6. If you do like fractions and you want to, exercise with them, I guess you could say. Yeah.
Okay.
Oh, yeah.
Oh.
If you like to work with fractions, let me show you a little trick. This is a 1, right? This is only convenient when you have a 1 involved. This is 1 over 6. The denominator dictates what you need. So you have to ask yourself, how would I write 1 as a fraction with 6? It would be 6 over 6, right? So then you could say, oh, this is just 6 minus 1, which is 5 pi over 6. You don't have to do that in your head. I have no problem with you relying on the calculator. Nothing wrong with that. Now, go to the extra examples and practice. It's not that I don't think you know what you're doing. It's just because of the pi and the fractions, some people tend to get these wrong because they're just not comfortable with pi and fractions. So 4 practice problems on the next slide, repeating the exact same concept. So you try them, and then we're going to check them. So the first 2 was the coterminal. That tells you that it's adding or subtracting 2 pi. So we have 3 pi. This one you could have done in your head, but if you're nervous that you might mess it up, then go to your calculator. So if we add 2 pi to this, we would get 5 pi. If we subtract 2 pi, we would get just pi, which means it's not enough, right? So you would have to take off another 2 pi to end up with negative pi. So multiple answers here. If you noticed that 3 pi is already like past a full rotation, past it, then you could actually subtract 2 pi and get your positive, which is unusual. Usually we have to add to get our positive. And then you would take that and take another 2 pi off to end up with negative pi. You didn't have to do that. You could have just said 3 pi plus 2 pi is 5 pi, so that's another possible positive coterminal angle. Either one works. You did have to get to negative pi though. That was a must. The next one, did you get 7 pi over 3 and negative 5 pi over 3? Yep. Has everyone had a chance to finish the bottom two? Okay, so complement means they add to equal pi over 2. Supplement means they add to equal pi. So those are your bigger values, so you start with them and subtract off what they're giving you. You should have found the complement to be 2 pi over 5. The supplement to be 9 pi over 10. And those two. I do want to say something. I said it before, but maybe I haven't stressed it again. What do you notice about the possible answers when you're doing coterminal versus when you're doing complement and supplement? Do you notice a trend? There's a pattern in terms of the type of answer you get. All right, let me call attention to it. When you're doing coterminal, notice they want a positive, they want a negative, right? When you're doing complement and supplement, what's the answer always? Positive. Because think of it as puzzle pieces. You're saying this rotation added with the one you gave me would give the 90 degrees or the pi over 2. So coterminal angles have a positive and negative desired answers. Complement and supplementary angles are always positive. Always. Okay? We are going to stop there, let you go to your homework and start working through that because it is dense. So I don't want to throw more new stuff on you.